Welcome to the Explainer. Today we're exploring a seriously fascinating paradox. We usually think of modern technology as a tool to just speed our lives up, right? Processing data at lightning speed, messaging instantly, and rushing from one task to the next. But what if we've been looking at our gadgets all wrong? What if we could actually use our high-speed automated technology to do the exact opposite, to slow down and connect with the hidden quiet rhythms of the natural world?
Okay, let's dive into this. Our technology is giving us this unprecedented capacity to bridge the gap between human time and biological time. By using things like robotic systems and even living devices, we're expanding our ability to author totally new interactions with organisms that experience life at a fundamentally different pace than we do.
The biological time-scale divide.
To really get why this is such a game changer, we first have to admit our own biological limitations. We are, for all intents and purposes, practically time-blind to the natural world. Look at this comparison. Human perception operates on a scale of seconds and minutes. We're super fast-paced creatures. But the biological reality of plants, that operates in extreme slow motion, unfolding over days, weeks, and even months. Because of this massive temporal divide, plants just look completely static to the naked human eye. Time itself is the invisible barrier keeping us from seeing how dynamic and alive the plant world truly is.
Section 2. Robots translating slow life.
But here's where our high-speed technology totally flips the script. We're now using complex robotic systems to act as temporal translators, bridging that time divide and expanding our capacity to observe the slow. Take a look at the insane lengths required to capture just a single moving plant sequence. 43. That is the number of days a custom-built robotic camera rig, nicknamed the Trifid, had to run continuously just to film one carnivorous plant for the BBC's documentary, The Green Planet. This ex-military rig literally had to perform motion-controlled tracking day and night, adapting to the plant's incredibly slow movements, just to bring its timescale up to a speed that makes any sense to our human eyes.
And we're pushing this robotic capacity even further in scientific research. Check this out, this is GROOT. It stands for the Generating Rhizodynamic Observations Over Time robot. It's a highly automated imaging system built to do something we humans simply cannot do: continuously monitor the incredibly slow, dynamic growth of plant roots as they grow underground in clear gel over weeks and months.
And this brilliantly illustrates the sheer mechanical endurance required to translate slow biology. Tracking this timeline, you can see the GROT robot monitoring root systems across 90 different containers. It moves systematically to capture data at 0 hours, 140 hours, 250 hours, and all the way out to a staggering 625 hours. By handing the observation over to a robot that literally never gets tired, researchers finally have the high-throughput capacity to uncover hidden behaviors. Things like circumnutation, which is the circular movement of growing stems that play out over a span of months.
Section 3. The Slime Mold Smartwatch.
So, robots are great for helping us passively observe slow biology. But what happens if we shift the whole narrative? What if we start actively caring for it, directly integrating it into the actual devices we wear every single day? This brings us to a groundbreaking speculative design out of the University of Chicago. Researchers engineered a device where the internal heart rate sensor is powered by the physical growth of a single-celled organism called Physarum polycephalum, or as it's more commonly known, a slime mold. The slime mold acts as a literal, living electrical wire connecting the circuitry.
Now, to make this work, the researchers introduced intentional friction into the user experience, meaning you can't just plug this watch into a wall charger. You have to literally feed the organism oats and water. When you provide that care, the slime mold thrives, it grows into a conductive wire, and boom, your heart rate sensor turns on. But if you neglect it, the living wire dries up, goes dormant, and your smartwatch dies.
Now, what's really interesting about this slide is the stark visual contrast. On the left, you can see how the dried, neglected organism completely breaks the circuit. But on the right, a vibrant, healthy, highly conductive living wire stretches across the gap, born entirely from the user's attentive care. The technology only works if you deliberately sync your daily routine with the slow, biological needs of the living organism inside it.
When researchers had users wear this watch for up to 14 days, the psychological results were absolutely astonishing. Instead of treating the watch like just another piece of disposable consumer electronics, users developed a deeply reciprocal relationship with it. They felt a profound sense of responsibility for its well-being, actively checked on its slow progress, and get this, they even experienced genuine guilt and sadness when instructed to neglect it. By embedding slow life into high tech, our capacity for empathy was fundamentally expanded.
Section 4. Syncing with slow biology.
This whole philosophy of syncing with slow biology isn't just for wearables either. We can expand this concept to transform our larger living environments, totally rethinking how we design our homes. Take the slowing home experiment, for example. In a typical smart home, you press a button and your smart curtains snap closed instantly. But in this experiment, researchers connected IoT technologies, like those smart curtains, directly to a houseplant's environmental microclimate. Instead of responding to a fast-paced human command, the curtains slowly open and close based entirely on the gradual natural shifts in the plant's local humidity levels.
This represents a radical shift toward what we call plant-decentric design. It forces our high-speed, human-centric smart homes to literally slow down and adapt to the biological pace of a simple houseplant. It really challenges our taken-for-granted assumption that a home's environment should cater exclusively to human speed, showing us how technology can actually orchestrate a shared, slow microclimate.
Section 5. Rooted in time. As we use technology to bridge this gap between the fast and the slow, it naturally leads us to a pretty profound philosophical arc about what it actually means to experience time, and honestly, even consciousness itself. There's this fascinating theory discussed on the Reddit consciousness community that suggests consciousness isn't just a single magical moment. Instead, it's a deep, temporally extended tracking of internal change. It proposes that the subjective feeling of being conscious actually emerges from a system constantly updating and comparing its internal states over time. Essentially, to be alive and aware is to be deeply anchored in the slow, continuous flow of time, which is something our fast-paced digital lives often completely strip away from us.
This need for temporal anchoring is actually a deeply ancient human concept. Think back to Homer's Odyssey. The ultimate proof of Odysseus' identity wasn't some magic trick. It was his secret knowledge of his marriage bed. As the legend goes, he built their marriage bed around a living, rooted olive tree. Because the bed was literally anchored to the earth, it couldn't be moved. It represented a marriage and an identity rooted in something slow, alive, and utterly unmovable in an otherwise chaotic world.
So, the crucial point is this. Our modern robotic time-lapse rigs, the Groot root trackers, and those slime mold smartwatches, they're serving the exact same purpose as Odysseus' ancient olive tree bed. They act as a temporal bridge. They use the very pinnacle of high-speed human engineering to anchor our frantic digital lives back to the slow, living, rooted Earth.
We've seen how expanding our technological capacity allows us to author absolutely incredible new relationships with the biological world. By translating the slow, we don't just see plants and organisms differently, we end up seeing ourselves differently. So I'll leave you with this to ponder. If our devices can teach us to see the slow, what other hidden connections will we uncover when we finally stop rushing? Thanks for joining me on this explainer, and I hope you take some time to enjoy the slow pace today.